y minus y over x minus x. Don't forget the midpoint, the slope formula. Okay, so that's why that was 5. Now I'm doing the midpoint formula because I'm doing the midpoint, so please understand that for this one I'm doing average of the x's, comma, the average of the y's. That's what's going on down here. So that is going to give me, okay, so that's negative 22 over 2, and that's going to give me negative 8 over 2. So that's going to be negative 11 comma negative 4. Alright, number 3. Midpoint and endpoint. I recommend always making a diagram. So it's like this. Alright, please understand that 3 comma negative 11 is a midpoint. Negative 7 comma negative 5 is an endpoint. Okay, I'm going to put it over here because I usually do. Negative 7 comma negative 5, that's an endpoint. So the other endpoint is my e comma f. So one equation is going to be negative 7 plus e divided by 2 is equal to 3. My other equation is going to be negative 5 plus f divided by 2 is equal to negative 11. If I multiply by 2 on both sides, that's going to give me negative 7 plus e is equal to 6. Okay, because I just multiplied by 2. If I add 7 on both sides, that's going to give me e is equal to 13. Okay, I did plus 7 plus 7. I just don't have a lot of room. Over here, if I multiply by 2 on both sides, that's going to give me negative 5 plus f is equal to negative 22. If I add 5 on both sides, that's going to give me f is equal to negative 17. So that's why the coordinates of this other endpoint will be 13 comma negative 17. Okay, the length. Alright, length is the same thing as the distance between the points. So I'm just going to do the distance formula. Okay, x minus x. So I'll do 4 plus 7 squared plus, alright, now I'll do y minus y, so that's going to be negative 5 minus 2 squared. Alright, just put that in the old calculator. I'm getting the square root of 170. Okay. Midpoint. What are the coordinates for Kenya's house? So we're doing midpoint, so this is just going to be the midpoint formula. Okay, average of the x's, average of the y's. So that's going to be 19, that's an x value, plus negative 15 divided by 2. And then the y value, so negative 12 plus 24 divided by 2. Okay, so that's going to give us just 4 over 2 . and then 12 over 2. So that's going to give us 2, 6. Alright. So, number 6. What's the approximate distance from her house to school? Alright, so this is just the distance formula. Okay, so x minus x. So, so 6 minus 7, say, squared. And then y minus y, so negative 3 plus 5 squared. So that's just the square root of 5. Is it equilateral, isosceles, or scalene? Well, we got 3 distances to do. We got to do PB. All right. Well, let's say this is P, B, and J. So we'll do PB. Then we'll do BJ. And then we'll do PJ. Okay, so this is going to be for PB, so x minus x, so I'll just do 3 radical 3 minus 0 squared. Now y minus y, so that would be 5 minus 8 squared. That gives me 6. Now BJ, so that's 3 radical 3 minus 0 squared, and then 5 minus 2 squared. That gives me 6 as well. Just put that in your calculator. And then finally PJ, well, the x values are both 0, so 0 minus 0 squared. The y value is 8 and 2, so 8 minus 2 squared. That also winds up being 6. Alright, since they're all the same, this is equilateral. Alright, circumcenter, this is the one where we have to do the perpendicular bisector. So here's the midpoint of AC. So this would be one of my perpendicular bisectors. Okay, I just need one more perpendicular bisector. This is the midpoint of side AB. Notice how it's going up 1 over 1. The perpendicular line will have a slope of that's opposite in sign but reciprocal. The reciprocal of 1 over 1 is still 1 over 1, but I will go down 1 over 1 because it had to be opposite sign. So down 1 over 1 is like this. So this perpendicular bisector goes like this. And you can see that here's where they meet at the circumcenter is 5, 4. Okay, so 5, 4. Coordinates of the centroid. The centroid is the one where we do the average of the x's and then the average of the y. So we're going to do x plus x plus x divided by 3, comma, y plus y plus y divided by 3. Okay, so that's going to give us, what's that going to give us? Okay, so here are the coordinates of A, B, and C, which I just looked at the graph and I saw where they were. So the average of the x's I think I'm going to need this space. So x plus x plus x, so that's 0 plus 8 plus 10. And then y plus y plus y. So that's 1 plus 9 plus 1. So this is going to give me 18 over 3. This is going to give me 11 over 3. Reduce this and you get 6 comma 11 over 3. Okay. So that's the centroid. Now the perimeter. If I'm going to do the perimeter, then I need all of the distances. Perimeter of a shape is just the sum of all the sides. So we need to find the 3 sides of triangle ABC. So that will be distance AB, distance BC, and then distance AC. So we just need to do that distance formula 3 times. Okay, so AB, first of all, that's going to be 8 minus 0 squared, and then 9 minus 1 squared. That's 8 radical 2. Now BC is going to be 10 minus 8 squared. Okay, and then 1 minus 9 squared. I'm getting 2 radical 17. And then finally AC, so I'm going from A all the way to C, so that's going to be 10 minus 0 squared, and then 1 minus 1. You know what? I really didn't need to do. AC is just the length of this right here. I'm looking at it. That's 10. Okay, so shame on me for setting up a distance formula. Okay, clearly AC is 10. It's the length of the bottom. Look, it's right there, 10. Okay, so the perimeter is going to be the sum of these 3 lengths. So the perimeter will just be this plus this plus this. Okay, so just put that in your calculator. You know what I mean? 8 radical 2 plus 2 radical 17 plus 10. In fact, you know, like as far as without a decimal, this is as close as you can get to the perimeter. But put it in your calculator and we'll find a decimal. That turns out to be 29.6. It's like 29.55991975. I'm going to call it 29.6. Okay, so there's that. Area. Please remember that the area of a triangle is 1/2 base times height. Okay, there's a sign at the front of the classroom that says the area of a triangle is 1/2 BH, but it's up to you to know that that's base times height. Anyway, looking at this picture, the base is AC. Okay, that's 10. You know, you could count the squares. But the height, you should be able to find the height as well just by counting the squares. This is the height right here. The height is the altitude of this triangle. Okay, if this is the base and this is the height, the altitude, this is going to be 8. See how it goes up to 9? But it's 1 off the ground, so I could count these squares, but it's going to be 8. So the base is 10 and the height is 8. So this is going to become 1/2 10 times 8. Okay, so that's going to be 40. Right, half of 10 is 5. 5 times 8 is 40. That's how you can do it in your head. 12. What is the distance between point A and the midpoint of BC? Okay, well, what is this point A? Let's put that down. Point A is 0, 1. Alright, what about the midpoint of BC? What's that? The midpoint of BC is right here. Okay, that's the point 9, 5, right? 9, 5. Okay, so we're just talking about the midpoint, no, the distance between these 2 points. Here's point A, here's the midpoint of BC. So we're just doing the distance formula once again. Okay, so 9 minus 0 squared plus 5 minus 1 squared. Okay, put that in your calculator. I'm getting root 97. Okay, number 13. This is from, what are we doing here? This is the day 10 coordinate geometry review part 1. But I'm just doing number 13 right now. So here's the deal. No, you will not be given graph paper, and no, you will not be allowed to bring graph paper. So I'm only using graph paper to make it more clear to you what I'm doing, but you'll have to make a rough sketch in the margins of your paper or something, or I'm hoping once you see it you'll be able to even just sort of do it in your head. But here's what you do. The isosceles triangle. Hopefully you understand that an isosceles triangle is one that has at least 2 congruent sides. So that would be an isosceles triangle, for example. If these sides were equal, that would be isosceles. That's what we're shooting for. But here's what we know. We have one vertex at the point 1, 2. So here's 1, 2. That's a vertex. We have another vertex at 1, 10. So 1, 10 is right there. Okay, so this is basically one side of the triangle. Now, we know that the other vertex is 9, something. So that means it's over 9 up something, alright? We're supposed to find out what this unknown value is that says how high it is. So here's the deal. So these are the possibilities, you know. We know it's 9, something. What is it? Is it 9, 1, 9, 2, 3, 9, 4, 5, 6, 7, 8, 9, 10? Alright, the question is which of these will form an isosceles triangle. So I'm going to encourage you to look at this side that's already formed. You know, the 2 points we're given. Look at that as the base of the isosceles triangle. Okay, look at this as the base. Okay, if you think of that as the base of the triangle, then now this is what we're asking ourselves. if I go like this, is that going to make an isosceles triangle if I pick this point right here? Okay. Hopefully you're seeing that this will not be an isosceles triangle, because what we're shooting for is for come back. We're shooting for these sides, to be the same. If we sort of look at this side over here as being the base. But this seems to be leaning a little bit too far to the right, if you can see what I'm saying. So the way I have it, these are not congruent. Now I don't want you to just guess at it. I want you to know exactly, but let me make this more obvious if I can. Okay, for example, is this going to be it right here? Okay, will this be an isosceles triangle? I tried to make it even more obvious that this triangle is leaning too far down. So the idea is, if I want these two sides to be congruent, it's going to have to be, this final vertex should be right on the axis of symmetry. In other words, it should be right in the middle of the triangle. So look, all we really need to know is what is the midpoint of this base. That will tell us where the axis of symmetry is. So let's see. How tall is this? It starts at 2, ends at 10. 1, 2, 3, 4, 5, 6, 7, 8. This base is 8 across. Okay? So from here to here, that's 8. So that means the midpoint must be 4. Okay, so if I count 1, 2, 3, 4, this should be the midpoint of this bottom of the triangle. That means that this is the axis of symmetry right here. Okay, that's the axis of symmetry. So hopefully now you can see why this triangle that we tried to draw seems to not be balanced. It seems to be leaning too far down because the axis of symmetry is up here. So let's try again, see if we can do better. If we make our triangle have its vertex right on the axis of symmetry, and remember, we knew it had to be one of these blue points here because they told us that the final vertex is 9 comma something, so it had to be over 9. It's just a matter of which one of these it is. But now we know that's now we know the axis of symmetry. Okay, so we will pick the one that's right on the axis of symmetry. So this should be it. Okay, so if we do it this way, now this vertex will be 9 comma 6. Okay, and now it will be a nice isosceles triangle because the vertex is right on the axis of symmetry. Everything is nice and balanced, 4 to the left, 4 to the right. That's what it takes to be an isosceles triangle. It should be right on the axis of symmetry. So again, comparing this 9 comma 6 that we came up with for the vertex of an isosceles triangle compared to 9 comma x, okay, that means x must be 6. 9 comma 6, 9 comma x, x is 6. Okay, and that's how you do number 13. Again, you won't have graph paper, but just in the margin of your paper, you would just make yourself a sketch by hand and go, oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you could just do your own graph similar to what I did And you could do the same thing and see that, okay, if it's 9 comma something, you know it's going to be over here somewhere. So the middle must be halfway. So 1, 2, 3, 4. The middle must be here at 6. So you could do the exact same thing and figure out that to make an isosceles triangle, that this would have to be, remember this is 9, so that would be 9 comma 6. So you don't actually need graph paper to do it, but you can imagine how hard it would have been for you to understand if I had done a rough sketch to teach it to you. Okay, but on the test, on any test, you can do your own graph and it'll be okay. Okay. Number 14. Calculate the slope of the line through this point. Okay, well, slope, of course, is, you know, y2 minus y1 over x2 minus x1, or you could do y1 minus y2 over x1 minus x2. Alright, as long as you do it the same way twice. So in this case, I guess it doesn't matter. So y minus y, so that's going to be negative 8 plus 8, either way you do it. Here I'll do 4 minus 1, x minus x. So that's going to make 0 over 3. Do not leave it like this. If you leave 0 over 3, I'm going to mark it wrong. Instead, put just 0. When the 0 is in the bottom, the denominator, that's when it's undefined. But 0 in the top is just simply 0. Last problem. Just another slope problem. Okay, again with the y minus y over x minus x. So y minus y, I'll do 7 minus 5. And then again, that would be negative 3 plus 3. So that's going to be 2 over 0. And I guess I just got through saying when the 0 is in the denominator on the bottom, it is undefined. Okay, that's it for part 1. The review part 2 is in a separate video.